All right, here we are, the next episode of All Things Facades, and we're going to focus on building envelope commissioning today. And I'm really excited for this one because we have Eliot Benor on. And Eliot is, I have to say, a good friend and somebody I like a lot, but in truth has an incredible amount of wisdom and experience to share. And interestingly, we actually have a similar background, both coming from the facade consulting side of the industry under Israel Berger, and then ending up on the window side of the industry. And now Eliot's taken it to a whole nother level. So with that, Eliot, you can introduce yourself.
Hey, good morning. Thanks for having me on, Adrian. Yeah, as you said, I founded Building Envelope Testing about 8 or 9 years ago. We're transitioning actually today. My sons are starting to take over more and more of the operations and management of the business. We're a boutique testing lab located just outside New York City, Middletown, New York, just the Hudson Valley. And we do building envelope testing, which is window testing, facade testing, air barrier testing. We do lots and lots of investigative work, leak investigations. And the last few years, we've been concentrating a lot on retro commissioning. So going to existing buildings and baselining the performance of their facade, both for performance regarding air and water penetration, but a lot more lately has been about energy. So we've been trying to help owners of buildings quantify how their facades are affecting their energy bill, because New York, like many other cities, has been pushing for carbon reduction, and buildings are a major sector in the carbon reduction world. So we've been doing our part to help out with the ability of governments, real estate companies, institutions to reduce their carbon impact.
So I know your background and the trajectory and how you came up in the industry, but it would be good to share for people. And, this is a strange industry where a lot of people kind of just fall into it and 20, 30 years later figure out, how did I end up staying? I guess talk about a little bit of the experience, but also, especially now that you're bringing up your own family and sons, how important is it, do you think, to have diverse experience in terms of not only potentially from multiple companies, but also seeing different sides of the industry, from consulting to contracting to manufacturing?
To me, it's been critical. I started as I was a machinist. I was trained. My dad was a machinist, and I was content to follow in his footsteps. Unfortunately, manufacturing wasn't really growing in the United States. And even as old as I am, it still started to leave these shores and go offshore. And I saw that happening, and my dad's business failed. And I had a friend who was doing replacement windows in New York City. And my brother and I had just rented a loft in Newark, New Jersey, to set up a little shop to do the work that we were trained to do. And my friend came to both of us after we had signed the lease and given the deposit. And he says, "You're crazy. You've got to come work for me for a month. See what we do. I get to see the air. You're going to be in a factory all day, breathing soot and dust and smoke." And we went out with him, and he did this kind of unique end of the business. He installed windows, but his big thing was he repaired windows. So he went around to buildings that had double hung windows or any kind of windows, and he worked out deals with management companies to do service on these windows to keep them operable and serviceable. And it was a great little niche. And that's how both of us, my brother Maurice, who works for Graham Architectural, and I learned about windows by fixing them. My friend who gave us that start was going in one direction. We wanted to go in a different direction. And we went off on our own. And my brother was somehow we got connected to a guy from Graham Architectural, and what happened, the story goes that we got called from a small condominium in Brooklyn. A lady's husband put a huge air conditioner in the window and sawed half the window out and stuck this 40,000 BTU AC unit into a window. We get there, we look at it, and we're like, he sawed out the sashes, and let's call the company. The super of the building gave us the company's name. It was Graham Architectural Products. Called them up and said, this lady's husband put a screw through the frame. It separated the thermal break. And this is back in like the early 90s. And there was a whole movement about port into bridge thermal breaks delaminating, and everybody was paranoid about it. So as soon as the guy from Graham, whose name was Bill Wilder, he was the head of technical services, as soon as he heard thermal break delaminating or separating, he said, "You'll fix it for us?" And we were like, "Sure, we'll fix it for you. How much will you charge us?" And we had no idea. We were already charging the lady in the apartment $150 to fix it if we could. And so we said $150. He said, "Oh, $150 an hour? That's perfect. I'll get you the parts tomorrow." He did. We repaired it. We double dipped on that one, I have to admit. And from there, we just got a relationship with them and started going out and going to schools, hospitals, city buildings all over New York, New Jersey, Connecticut, and doing punch list work, basically. So they would finish a project, couldn't get the last 10 pieces of glass that broke during construction, hardware broke, there was 2 windows left to install, and we'd go and complete it because it was a job of 2,000 windows, a 4-page punch list with what the installer considered bullshit. So we would finish up that bullshit and release $500,000 worth of money to them, and they loved us. It was a
How
great
much so how often were the building owners coming to you versus the contractors versus manufacturers, and where did warranty come into play with here? Because it seems like a gray area.
Back then, so these were recently completed jobs for the most, not always, but a lot of times it was recently completed jobs, and it was mostly window manufacturers. We worked for them. We worked for a company called Seasonal, who's no longer in business, Traco, Champion. We used to work for all the window manufacturers back then, and it was great. Graham was obviously our biggest customer because they did a lot of work in New York back then, and we did a lot of warranty work too, especially on insulating glass, and that's what the next phase was. We had a lot of trouble getting insulating glass. We order it. The local fabricators weren't real good at doing short orders. They couldn't do anything with light gauge glass. We'd order something with 1/8-inch glass lights. They'd come out with 1/4-inch glass lights. We'd put them in the window would slam shut. So we figured out that we had to start making our own IG units. And we bought a little hot melt butyl machine that probably a lot of the people listening to this have used in their lives, and started cutting glass in the basement of my mom's house that we had to pick up because no one would deliver glass to us. So we'd drive out to a place called Merchant's Glass in Long Island, pick up a crate of glass and bring it down into my mom's basement, 10 sheets at a time. And we'd make the IG units at night and go out the next day and replace them, either for building owners, under warranty, things like that. And it expanded. Eventually, we let go of the service business and just tooled up and manufactured IG units on a large scale. Our accounts were the Housing Authority in New York and Newark, Plattsburgh. We'd make replacement glass for their housing projects, schools, and supply it to them. And they had glaziers who would come in and change it. And that took over. We fabricated glass for about 10 years. Tough business, especially back then. We were working on pennies. As a matter of fact, Skyline Windows was one of our biggest customers back then. And eventually it failed. It failed because we weren't big. And we were in a market where in order to grow, we had to make a major investment. And I don't think either one of us in our 20s, maybe I was 32 at the time, neither one of us was ready to buy a tempering oven, a building to put it in. We didn't have credit to do that anyway. We were young guys just working hard. That's all we knew. And so we came to the point where we said, you know what, we both had enough. We had really good offers. My brother went to Graham at that point. I went to EFCO. EFCO was very big in New York. Guy who was the EFCO salesman was a gentleman named Ed Budney. Some people may remember him. He was a really good guy. He brought me up in the business, introduced me to everybody in New York in the glazing business, in the window business. And my years at EFCO, or as the EFCO rep, because we actually repped other lines, were really great for me. If there was a place you wanted to go back then to learn windows and curtain wall, it was EFCO. They ran training twice a year for salespeople and customers. It was awesome. It was really awesome.
So you must have been selling to Skyline at that time.
Somewhat, yeah. We had a few jobs. There weren't a lot of jobs. Skyline was already making their own windows at that point. Even when we were in business, I remember David Krause used to come to because our original fabrication shop was in Brooklyn, 10 minutes, not even 10 minutes from the Skyline's original factory. And David used to bring sashes for the 100. That's the double hungs, the 100, right? They were developing the 100 back then. And because it was an oddball size glazing unit in that, it was 1.25 inches, I believe.
For the acoustic requirements, yep.
Right. So they were the only ones really making an 1.25 inch, 2 light insulated unit. So no one really had spacers, and we were working out the spacers with the spacer company and making sure the tolerances worked with the marine glazed gaskets, because Skyline never marine glazed anything till that point. So it was a lot of trial and error to get it right. And I remember he was really good to us. He really was great to my brother and myself. He was really a role model. You know, when you know his story, it was really, I can't say enough about him. But then I went to work for EFCO. I was there for a few years. I liked it. I really, really enjoyed it. But I was young, and, you know, I saw all these things happening, and I became friendly with a guy named Mark Weisbach. And Mark kept telling me, well, if, you know, you ever want to try, come on board. We need people. And I was always afraid to go into the consulting side. But Israel convinced me that, you know, your glass knowledge will be very helpful, blah, blah, blah. Which
what
it was.
The fear? What was the fear at the time, given the consulting side was so new?
You know, just that it was new. Nobody knew about it. I didn't have a degree. I wasn't an engineer or an architect. I thought that was a prerequisite. Probably today it is more of a requirement than it was back then. But, you know, Israel convinced me that we need people who actually know how to do it. And so I went there. Also, great time. Israel was another great mentor. I talked to him a couple of months ago. We stayed in touch over the years. I see Mark every once in a while. He happens to live 5 minutes from one of my uncles. So every time I'm over at my uncle's house, we run into each other while he's walking his dog. And I stay in touch with some of the people, or a lot of the people that I met when I was at Israel Berger. Now this is going back a long time ago, but yeah, we all try to stay in touch as best we can. I learned a lot. Israel sent me all over the world, all over the country. I did projects in St. Louis and Tel Aviv, all over, and it was great learning experience. But one of the things I learned was, although technically I was a good consultant, I wasn't great at the business side of consulting. And I respect the people who can do both things well today. It's really hard to have both those skill sets, to be able to do the consulting side and remember that it's a business, right? Because it is a business, and if you can't get paid, you won't be consulting for very long. And I guess that was the part I was really bad at. And having answered my pants as I did, an opportunity came up to go to work for a company called Fulton Windows that became part of Old Castle Glass, I don't know, 10, 15 years ago. And Fulton was a small family-owned specialty window and curtain wall company. They were one of the first companies, or maybe the first company, that made a unitized curtain wall system that was available to glazing contractors. And the whole way they did things in Canada was different. They try to pre-glaze as much as they could, or pre-assemble everything. We were still stick building things. They were already pre-glazing and unitizing windows, curtain walls. I was amazed. I met the gentleman who was the vice president of engineering. His name was Werner Kloek, German-Canadian guy, one of the real founding fathers of unitized curtain wall. He really was around at the beginning. A company called Laura Lee out of Canada that was a division of PPG. And he knew it. I mean, he really knew it. You know when you meet people and they know it. He knew it. He knew it so well that I was convinced that being able to work with him and be mentored by him was worth whatever I had to do. So I went back to Israel, and I said, listen, I've got an opportunity to do something. Everything was good, no hard feelings. I went to work for Fulton. I was with them on and off for about 12 years. We did jobs, lots and lots of jobs all over. I had an opportunity to manufacture unitized curtain wall. I spent a few weeks in the factory working on the line. I spent a couple of weeks in engineering, learning engineering of curtain walls. I was lucky enough, till today, I have an HP calculator here somewhere that I was given by Werner. It's a relic now, but this is how I learned how to do
Yep.
beam deflection and thermal expansion and everything else was on an HP 48 or now a 50, which I'm sure the batteries have gone dead in it by now. But and I went out in the field and learned how to lay out and install unitized curtain wall, because I was trying to sell into a market where everyone I met had worked for diamond glass loom until I got on the site and I realized nobody knew how to install it. So we realized I needed to learn how to do that to be able to teach the glazing technicians, the actual iron workers and glaziers, how to properly do it, because they were trying to install it the way they'd install a stick system. And that went well for a long time. Oldcastle bought them. I'm not the corporate guy. I really didn't fit into the Oldcastle universe. So basically 6 weeks, 8 weeks after they took over, I said, guys, I'm going to try it on my own. And I just went off and did a few things over the years in between then and starting the company, but mostly I was a rep and did technical sales for people, and eventually wound up doing some testing. And I was testing at ATI in York for a couple of customers of mine who had issues and needed somebody to actually take over and run mock-ups for them, basically. And so I was doing pretty well with it, again, till another corporation took over. Intertech bought them out, and basically the way my thing was working wasn't viable to them anymore, and decided to buy a truck and build some testing equipment and went into the testing business. It's been
So I think I'm going to interrupt here, because what I want people, as we progress the conversation, there's a lot of topics today, what we're going to get into when it comes to codes and real application. But Eliot's experience, as you could see, really ranges from every side, from servicing the windows in the early days with his brother, spending time on the manufacturing line and engineering in the production facility with Fulton, seeing fabrication of different type of units all over the world with Israel Berger. So that real life type of practical experience is invaluable today. And I think he's coming off as a little bit of an imposter, having a little bit of imposter syndrome, because the truth is Eliot would make for a great consultant, even though he doesn't think so. So with that, you went on to start building envelope testing. And before we get into that, was all those years when you were with these different window manufacturers and contractors, was it very common to see the large testing agencies on site, either doing quality control testing? Where did that play out in the 90s and 2000s?
Yeah, I mean, it was early, right? It was Saks down in Miami, or Henry Taylor opened up in York 10 years later, whatever it was. And there was Heitman out in St. Louis, but yes, it was basically, other than Saks, the rest, and Saks and ATI, everyone came from the consulting side and opened up a testing lab to support their consulting. But yeah, we were getting, especially in the major markets, New York, Chicago, all over Florida, because of the failures, you did see field testing, and especially on co-op and condo, because the legalities, if you didn't have something that was a tested custom system, because most systems were custom at that point, if you didn't test it and have a report that says it passed the test, you left yourself open to lawsuits later on if there was a leak, or even if there wasn't a leak. So mock-up testing started to really grow, and today it's grown very, very large. And yes, it was out there, and it's how I started, because when I had projects, I'd make sure that I got out there ahead of time and ran the electric line for the lab and made sure the water was set up for them and the area was clear. And then you work with the guys and you get more and more familiar with what they're doing to test. And, that's how I got the knowledge or the confidence to say I would start doing more testing.
When you first started, was the focus or thought that you were going to focus on performance mock-ups, or equally as much of the business would be field testing and commissioning?
It was all field testing at the beginning. It was all field testing. For the first 4 years, I would say we didn't have a facility to do mock-ups. We had a small 1,000-square-foot garage, but it wasn't suitable for mock-ups. And I always hoped that we would get to the point where we could afford to set up a lab to do mock-ups. And slowly we did. We squeezed into some buildings that weren't really great for mock-up testing, but we made it work. The business is changing, again, driven by energy, I think, a lot. So we see less, at least in the major markets, we see less and less full glass skins right now. and more mixed facades where it's an opaque wall with punched windows, a section of curtain wall, especially on high rise. You know, people love glazing, people love aluminum and glass. It's beautiful, very, very efficient. It's inexpensive compared to other things, and you have a single source, right? I've written LinkedIn posts about how aluminum and glass are the perfect building materials, except when it comes to energy. When it comes to energy, they're weak, and we have to do, not that they can't perform well, but we have to do a lot to them to make them perform well. And honestly, the industry hasn't done a good enough job of understanding that this is critical to our future, is letting go of the old thinking that as long as I hit a price point, I'm going to be able to get my market share next year.
So we're going to get to energy later on, because I think that's been a focal point of, I'll call it, the last 3 years. It's all I read about, all I talk about with people. But let's go back to maybe even 2015 or so, when I was on a project with you at 5 Manhattan West, the Reclad project with the Permasteelisa curtain wall. So I was on the facade consulting side, and Eliot was testing the facade system. I think you were married with Kleb on that project to develop the actual chamber and what you were going to do on site to navigate getting around those zipper panels. So one thing that would drive me crazy is that the specification would call out for a specific testing protocol, first units that go in, intermittent testing, and we would pinpoint weak areas, one typical section, and then some of your interface conditions where the test would be conducted. But the reality is, I wouldn't see you on site until 80% of the facade was already installed. So how much of this do you see it as owners or contractors just checking a box on a specification versus actually getting the real value and identifying issues or leaks on site early on?
Great question. Great question. It's not just for field testing, but it's the same for mock-ups, right? I tell people, we're not there to make you guys pass or fail. We're there to perform the test and uncover problems and issues so that we can fix it before we get half of the building installed. Because once the frames are up, once the glass is in, the metal is on, it's the most expensive time to fix it. And that's really what we're doing. Listen, every job, every major monumental job, whether it's a 4-story hospital or a 45-story apartment building, it's got unique conditions, like you just said. And then they're produced in a factory. And, especially after COVID, production's not easy. Supply chain issues, quality control is not as stringent as it used to be. So really, we look at ourselves as the last check on everything. And you really want to do that check before you get too many units installed on the building. Now, it's not always feasible, because there's a lot of other trades that have to be coordinated and things have to happen. Having water on site is a difficult issue lots of times at the beginning of a project, but we try to push people. And we're working for a lot more owner developers and institutions than we used to. So now we're working directly with universities, with larger developers who realize this test is not to judge or to hurt any of the parties involved. It's actually to help everyone. And it's important that every participant looks at it that way and doesn't just look at it as a piece of paper that says pass. Because honestly, we're going back consistently to jobs that passed a test, but really didn't do enough testing to justify confidence that what was being installed was good and was going to perform as it should.
Well, I remember it's so funny, because now that I'm on the contracting side, I lose sleep at night the night before a test. Whereas when I was on the consulting side, I remember some of my peers and mentors would say, there's no point of sending you to a 3-week mock-up if you don't, witness or exposed to any issues, because that's where you learn from it. So more so seeing it as not just checking that box, but no, we'd rather identify that issue early on to expose any of the weak areas or vulnerabilities in the system.
Yeah, and that's critical on the mock-up side. So our approach to mock-ups has been a little different than most of the other labs. Because we see less unitized all glass walls lately, and because there's a lot of capacity for those types of mock-ups. There's 5 labs in our area that can provide that service, and between them they have over 100 test chambers. So it didn't make sense from a business point of view or from a future growth point of view to just duplicate what everyone else had. So we came up with this idea, well, most of the jobs we're seeing now are mixed opaque walls. So they'll either be block walls, dense glass and stud walls with some kind of cladding on it, a cavity wall with insulation, some kind of sheathing or block, insulation, and a cladding. It could be brick, it could be metal panel, fiber cement panel, whatever they're putting on the cladding on the outside. Today, most jobs are rain screen walls with punched windows that we see. And a traditional steel mock-up on a steel back wall doesn't really lend itself well to doing that effectively or at a reasonable cost. And the reasonable cost was big for us. When we started thinking about how we were going to do mock-ups, we said, this has to be affordable. Otherwise, people aren't going to do it. So we came up with this reusable, pretty fixed size opening. So it's a 3-sided room. It's 2 back wall, 2 side walls, all made out of CMU with a roof. The roof we'd put on usually after the windows or the walls installed and close it off, but we also have done it where it's fitting inside that box, that room with one open wall. And we talk to the owners and the contractors and we tell them, listen, when you buy this job out, negotiate with the carpenter to include a wall for the mock-up. In other words, he's going to bring the steel stud, the dense glass, everything he needs. He's going to put up that mock-up wall. The waterproof is going to do the waterproofing. Window guy is going to do the window. HVAC guy is going to do the HVAC. We want the guys who are going to be on the job to be at our lab and to do it under controlled, observed conditions. So we want the facade consultant, the engineer, the architect, to have someone there during the install of each one of these items so that they can see the coordination issues, make notes, make inspection points, and look at it holistically, because it's not just the window test. And too many people think all we're doing is testing the window. Today, that's not how the walls are complicated today. Air barriers have to intersect. They all have to work together. Structural issues. When I started in this business, there was no such thing as a steel stud exterior wall with gypsum sheathing, right? We built out of block and brick. That's how we built buildings back then. We knew how to do it, and it was a pretty durable system. Today, we have very light materials that we're trying to push to their limits to perform on very tall buildings. And if we don't get it right, we're going to have failures. So we figured that the mock-up that we provide at a very reduced cost from, traditional mock-ups would be a good way to do that. And it has been. We've seen that, people find out. People figure out waterproofing details, lintel details, insulation. We didn't insulate the cavities in the old days. Today, every cavity's got insulation, and tons of insulation, as a matter of fact. So that was one of the things that I felt was real important. And we can do the full barrage of tests pretty much. But what we find is that people really just want to make sure that they're not going to have leaks. The wall is going to perform for air, water, and structural the right way. And then we give people the options for thermal cycling, for condensation resistance, movement. Some people do it. Some people think, I really am most worried about water leaks. That's what most people are worried about, water leaks.
So I'm glad you went there. There's 3 things I want to touch on. So now let's get to actual site testing. Obviously, there's water, there's structural, and there's air. So let's touch on each one at a time. When it comes to water, what is the #1 cause of leaks that you find on site?
So are we talking overall or just within a window system itself?
Both.
So overall, it's the interface. It's most of the time it's the interface. Air barriers are widely used now. We didn't even know what they were 15 years ago. Today, it's on every job. Unfortunately, there is not the same level of precision as there has been on fabricated products like windows and curtain walls. So, waterproofing is, we like to say, it's sold by the bucket or the roll, and it's put up by a laborer usually, right? So is the laborer putting it up right? Did they receive any training? Is anybody inspecting it? One of the biggest complaints I have is we call people facade consultants, and they're really only looking at the windows and the curtain wall. Nobody's looking at that air barrier, which is really your water barrier. In the end, that is the water barrier. It's being sold and specified as the air barrier, and it functions as the air barrier, but it's your primary defense for water getting in through that wall. So we see a lot of air barrier issues or interfaces between the air barrier and the window that causes a lot of leaks. Also, in our market, which is mainly New York City, we've been seeing a lot of overseas products coming into the market. And the performance levels and the types of performance tests and even the levels of performance that we expect here don't exist overseas. There isn't. They're much more interested in thermal performance than they are in water. So if it doesn't leak during a storm, basically everyone's happy. right, in Italy. But here we have to make sure that it doesn't leak at a sustained 15 PSF static test, which is a durability test. I tell people all the time, make no mistake, when we do a static water test, whether it's in the lab at 331 or in the field in 1105, that is a durability test. It is not to simulate storm conditions. We are looking for defects in the system, in the installation. That's what that test is. That test is not to duplicate a storm. The test that duplicates storm conditions is the one you see with the airplane propeller. That is a storm test, but the regular water test that we see with static pressure is a durability test. It is there to uncover defects in manufacturing and installation. It's what I think a lot of architects don't understand. And you should judge it that way because, you know, going by the letter of the law, if at 14 minutes and 59 seconds I see a drop of water that passes the plane of the window, it is a fail.
So let me ask you, where do you balance practicality versus theory? Because after 14 minutes of negative pressure, you see a droplet. But think about how many buildings throughout New York City, they accept the fact that a droplet gets in here or there, it gets in the cavity, and it's going to dry out.
So even if it doesn't get in the cavity, if it gets on the sill of the window, is that a fail? That's a question we have lots of times. I'm on just about every ASTM and AMA test committee there is, and it's one of the hot topics of conversation. And you know, my personal opinion is that it's up to the professionals and the owners to look at it and understand. And if you don't understand, to ask questions like, what does that 15 PSF mean? Or what does that 10 PSF mean? And then say, make a judgment call. Am I still okay? Will we still be able to comfortably offer this building as a high-end building lots of times and know that we're protected? And our advice always is, especially when there's inconsistencies in specifications, which there almost always are, we tell everybody, listen, you have the difference between the test pressure that's in the spec and the rating of the window. Let's do one test with the lower test pressure, see how it works. If it fails, we don't have a discussion. We have to fix it, right? There's a problem. But if it passes, then let's move on to the higher test pressure. And I think that's something that could be should really be talked about more often. Personally, I think some of the testing's a little stringent right now. I don't see any reason to do a 12-pound field test unless it's a 40-plus story building and you know there's going to be sustained winds up at the top of that building that require it. On the other hand, people want to know, and there's professional liability issues where no one wants to accept lower than what's on paper, and I understand that as well.
I guess when you're testing, when you're doing a pressurized test at 12 or 15 PSF, if you don't get that leak until 13 minutes, you know, if there's an underlying issue, there's a void in the structural silicone joint, there's a missing gasket, you're not getting adequate adhesion of the sealant. I would think of it as a layperson. If you're going to have a failure, you're going to have a failure. If it's going to leak, it's going to leak within the first 2 or 3 minutes. So what does that typically mean if it would take so much time to see that first droplet of water?
It means there's an air leak. I brought up European companies and systems before. So the European systems are designed very differently. They rely 100% on pressure equalization, which means you're making a nearly perfect air seal on the inside face of that window. Most windows today have 2 or 3 lines of weather stripping. That innermost one has to be performing 100% for it to pass that 15 PSF test. Now, that means if you have a tiny, tiny void in the gasket at the top of the sash, let's say, or a non-continuous heel bead on the fixed glass, you're going to slowly draw more and more water in until it overcomes the system. And when we see leaks that happen within the first 3 minutes, it's a major one. It means something is wrong. We need to investigate and figure out what wasn't done right. Hardware needs to be adjusted. Gaskets get checked, sealants, all those things. Hell, sometimes they forget to put a screw in a hole. That's happened plenty of times. But when it takes a real long time, it's always air. Don't forget, this is a static pressure test, meaning we are putting a constant negative pressure on the inside face of that window or a positive pressure on the outside face. We are trying to force air through tiny holes to see if they're going to fail. If air never creates a suction to draw the water up through the drainage system and over the gaskets, it'll never leak. But it's almost impossible to get it so that there's no air leakage on the inside surface of the window. So That's when we see it. Now, the question is that ever going to happen? Not in real life, but in a major hurricane? I can't say it'll never happen, but in Mother Nature, there is no such thing really as static pressure for 15 minutes on a window, or it's very, very rare. Let's put it that way. Doesn't really happen very, very often.
So this is where it really comes down to expectations, I think, in different markets. So coming from the consulting side, I'm accustomed to special inspections where ultimately the building owner wants to get their TR technical requirement or technical document sign off so they can turn over the units and get occupancy. At what point does this become a life safety issue versus a judgment called by the owner? If you have a little bit of air infiltration or a leak, they could probably still get occupancy and say, we're going to continue to deal with that or deal with it later. Whereas if you're doing embed testing or pull testing or structural testing and you get a failure, that's an issue, has to be addressed at that point in time.
So yes, there are, as you mentioned, embed and anchor testing. We do a lot of that. Well, we don't do as much as we used to, but we do some of that. That's not done enough, in my opinion. I think it should be done spot checked on every project. Today, we are hanging things off the edge of the building called walls, right? Every wall is built hanging off of the edge of the building nowadays. Very few are actually sitting on the slabs anymore. And, or just more and more of them are hanging off the edge of the slab lately, I should say. And how they're attached to the building, we are attaching it to concrete. And we think of concrete as this very uniform, homogeneous material that's the same all over the world. It's not even the same on one floor, right? We have 50 trucks coming to pour concrete for a floor, and every load is a little bit different and going to have a little bit different properties. Anchors are made in a factory. They're probably pretty consistent, but they're installed by a construction worker who may not know how to install them correctly, may not know how to deal with things that aren't optimal. And I believe that life safety issue has to be checked all the time. Structural sealants, structural glazing. I believe you can't be too careful with structural glazing. It needs to be done. We know how to do it. The manufacturers of the silicones have done tons and tons of research, have the resources, and yet we go to lots of factories where no one's doing, practical, simple testing to ensure that they're getting good adhesion. The cure times are good. The material's within its expiration date. It hasn't expired. The ratio of the two components is correct. All these simple checks that should be done multiple times during the day don't always get done at a lot of the factories that we see. And, the evidence is we see glass being cut out with striations in the structural sealant.
So we're going to get to energy later on because I think that's been a focal point of, I'll call it the last 3 years. It's all I read about, all I talk about with people. But let's go back to maybe even 2015 or so when I was on a project with you at 5 Manhattan West, the Reclad project with the Perma-Silica curtain wall. So I was on the facade consulting side and Eliot was testing the facade system. I think you were married with Kleb on that project to develop the actual chamber and what you were going to do on site to navigate getting around those zipper panels. So one thing that would drive me crazy is that the specification would call out for a specific testing protocol, first units that go in, intermittent testing, and we would pinpoint weak areas, one typical section, and then some of your interface conditions where the test would be conducted. But the reality is, I wouldn't see you on site until 80% of the facade was already installed. So how much of this do you see it as owners or contractors just checking a box on a specification versus actually getting the real value and identifying issues or leaks on site early on?
Great question. Great question. It's not just for field testing, but it's the same for mock-ups, right? I tell people we're not there to make you guys pass or fail. We're there to perform the test and uncover problems and issues so that we can fix it before we get half of the building installed. Because once the frames are up, once the glass is in, the metal is on, it's the most expensive time to fix it. And that's really what we're doing. Listen, every job, every major monumental job, whether it's a 4-story hospital or a 45-story apartment building, it's got unique conditions, like you just said. And then they're produced in a factory. And, especially after COVID, production's not easy. Supply chain issues, quality control is not as stringent as it used to be. So really, we look at ourselves as the last check on everything. And you really want to do that check before you get too many units installed on the building. Now, it's not always feasible because there's a lot of other trades that have to be coordinated and things have to happen. Having water on site is a difficult issue lots of times at the beginning of a project, but we try to push people. And we're working for a lot more owner developers and institutions than we used to. So now we're working directly with universities, with larger developers who realize this test is not to.
Well, something I want you to talk about a little bit is these issues that we come across, whether it's structural sealant, interface details, and failures. Is this more of a systematic error? And I think the answer is no, or more so a quality control and labor or workmanship error, meaning applying that structural silicone joint, but not applying your primer ahead of time. So not necessarily poor detailing or improper use of certain system types, but ineffective quality control or workmanship.
So we see both, but yeah, the majority is poor quality control or no commitment to quality control because people just think this is the way we've been doing it, or this is the way the other guys do it, and we're doing it the same way they do it, not understanding how critical each step is. And, even we talked about embeds, torquing every anchor on an embed, right? So we're putting a P-clip on the top of the slab or the front of the slab for a curtain wall. Is someone torquing it? Are they sounding the concrete before they put the anchor on? We won't do an embed test until we sound the concrete and listen for air bubbles because you get them. You get air bubbles in concrete, and if we yank on one that has a big void in it, it's coming out, and it's got 10,000 pounds of force on it. It's going to rock it right out of our head. So we're pretty careful about it, and I think people installing should be. Our industry again needs to do more to educate. Probably more to set better standards right now and get, control of our risk, mitigate the risk of the manufacturers and the installers. It's on us. We can complain all we want about the cost of insurance, but until we get serious about creating an environment where it's not just about the guys wearing harnesses, but about everything, every aspect being safe.
So you're talking about a new construction application where you have a Hilti channel embedded in concrete, and if you do a pull test on that or torquing, and you see the concrete starting to spall or crack, that's an obvious underlying issue. But if you think about an existing building condition where you're doing pull testing on the surrounding opening of a rough opening of an existing window, what would that look like? Because I know a big focus area of yours now is window replacement applications and all these reclads and overclads. So understanding existing structures, if you're doing a pull test on, a lintel or a surrounding stone or brick opening, what would it mean? Just the whole wall collapsing?
No, usually it's movement so a lot of times when they're doing a replacement style install, they're leaving the old wood or steel frame in place and jumping over it, sometimes using it for anchorage. So when they're using it for anchorage, we want to check that it will resist the loads. And wind loads have changed in most building codes over the last 30 years. ASCE 7's changed in the last 20 years. So we have different loads. Some have been reduced, some have been increased. But we really do think about it a lot more today than we did in 1978. We think about the wind load and how it affects the buildings. The tighter buildings get, the more important it is to think about wind loads, both windward and leeward side of the building, and internal pressures. And all that is in ASCE 7 now, as you know. And testing an existing frame means making a custom setup to anchor a plate, which is usually multiple layers of plywood applied to that existing frame in a way that duplicates the intended method of anchoring the new window to it, and then pulling on it, because most of the time we're behind a layer of brick and the suction isn't as concerning as the pressure is. So we'll be pulling on it, but we've done both directions. We've done positive and negative loads on it and seeing what happens. Now, we do have the ability to measure displacement during that test. So we can put, we call them linear variable LVDTs or string potentiometers that we can connect to the frame and measure the actual displacement under load, or we can just look for visual evidence of a failure. Most of the time we're looking at visual evidence.
And so what I'm thinking about, especially with a lot of these window replacement applications, I appreciate your comment about jumping the frame, and it's common in New York, but you go into other markets and they want to just completely gut the whole opening. So a remedy to the new energy codes has been utilizing triple glazing. But especially if you have a putty sloped or putty glazed steel window with a monolithic piece of glass, and all of a sudden you're putting in a new triple glazed window, that opening might not be able to withstand that weight.
Yeah, absolutely. I mean, that lots of times I personally think should start with an engineer who comes in and evaluates the structure. We are adding a lot more weight. Most older buildings are overbuilt, so it shouldn't be a problem, but somebody should evaluate that who can, you know, make some calls on the structure of the building. With the dead load, that's the important part. So as long as it's an older building, a multi-white brick building, they should be fine. But yeah, get a good engineer in who understands structures of old buildings to look at it and make that judgment call first. Then we can do lots of different tests to verify that it's going to work.
So you have a water leak, you're going to get everybody's attention. No owner wants to deal with that from a liability standpoint. So everybody sees the value. Structural, it's a life safety issue. I think it makes sense. I think a lot of people overlook the third, which is air, infiltration, exfiltration, and they don't see the significance of it. All right, I have a little bit of whistling, or you're exposed or accustomed to it in high-rise buildings, but seeing your videos of the smoke tests with different colors, I think that highlights the significance of it and really draws a lot of attention, because otherwise it's just sort of a secondary item that you check a box. But why is air infiltration so important, not only from an occupant comfort standpoint, but also performance when it comes to heat transfer and energy performance?
So air leakage in most buildings is happening 24/7, 365. And that's the real problem with it. Now, again, the air leakage test that we do on windows is a durability test. So again, it's at a higher pressure than normal conditions. It's not directly related to energy unless it's bad. Because if it's a bad air leak, then you're losing a lot of energy through the windows. But I do lunch and learns for architects and engineers, and I bring party balloons with me. I blow up a bunch of party balloons before I start. And when we get to air leakage, I throw the party balloons out. And a party balloon is about 1 foot in diameter. And I tell people that's a cubic foot of air, right? It's 1 by 1 by 1. That's a cubic foot of air. What does CFM mean? It means one of those every minute is leaking through your wall, your window, your door. And it helps people visualize what it means. And I say, how many of these balloons do you think would fill this room? 500, 600. So if you're leaking 50 CFM, 50 of those balloons in a minute, how many minutes will it take to change all the air in this room? And how much does it cost you to reheat or recool all that air every hour? And that's why we measure air leakage, whether it's blower door testing on an entire building, facade testing, window testing. Air leakage is important primarily because of energy. But there's one more thing. When you have cold air from outside hitting the back of a wall, whether it's going under the sill of the window, through a penetration in the wall, it hits the warm side of that drywall on the inside. It makes it colder, and you have warm, humid air lots of times, especially in residential buildings, that now wants to collect on that surface. And you have chances increased for mold growth or some other growth of something that we don't want in our buildings. And the best way to keep that from happening is limit bulk water, which we call leakage, right? Because it's those slow leaks through the windows that really are problematic with mold, and limit air leakage or avoid air leakage, uncontrolled air leakage as much as possible. I'm much less concerned with a sash that leaks on a double hung at a meeting rail than I am in the air that's getting around the window into the cavity between the sheetrock and the framing, on the insulation, and giving us a perfect environment, or one of the things we need to create an environment for mold growth. That's just as important to me as the energy. We go into buildings that literally have to be evacuated after we start doing a leak investigation because we've got carpets of mold on the back of the drywall. That isn't even supposed to force the mold growth, but the glue for the facer on the drywall, they feed on it. The mold will feed on that. And it's crazy. We see it more and more, especially again with the lightweight construction we see in buildings today. Making buildings more airtight has actually had an effect on how much mold we see in buildings, because before the walls were so cold, they never got warm enough to create an environment for mold growth. Well, now we're insulating them and we're making them more airtight in some places. So leaks are more important, because if you do get the leaks in, it's a great environment in that wall cavity for the mold to grow. And on the energy side, it, like I said, it happens pretty consistently every second of the year. I tell people there's 8,760 hours in a year. And if you are losing air, or air is infiltrating into your building, every hour is costing you lots of money. We have to create more airtight buildings. And for the window industry, we've done a really good job of it. We really have. You'll be hard pressed to find too many windows that leak so much air that it's a problem. It's everything around the window that's the problem. But the window guy's always blamed.
Of course, which is why you're going to stay in business. So the last point that you harped on is energy and thermal performance. And I think for many years, it was an afterthought, if not even completely irrelevant. And now, as I was listening to you talking, we have two programs in place. One with a lot of these passive house buildings, which really promote or put to the forefront air tightness testing, blower door testing, and actually commissioning and ensuring that you get that airtight envelope. And the second thing is Local Law 97, which actually measures the carbon output or the energy output of your building. So for a while, I think there was this disconnect between proper detailing and design and specification of facades, but then not actually following through with what was being built and testing and ensuring that you got what you actually bought. So how do you see some of these new standards like 97 and passive house becoming more relevant, and the significance around commissioning and owners actually wanting to know they got what they paid for?
So we're at the infancy stage of commissioning right now. Building commissioning and building envelope commissioning are two different things. Building commissioning has basically been the mechanical guys making sure that the systems work, starting them up, handing over operations and maintenance manuals to the building people. That's got a more developed and a more mature system in place. But building envelope commissioning, which is part of the overall commissioning, is really just developing now. We don't really have an organization yet that sets standards for it. We're getting there. IBEC and other organizations are trying to put together programs for it, but we've got a ways to go yet. It's critical. It really is critical and it's what we've been doing in a lot of the biggest cities. We used to call it consulting and testing. Today it's called commissioning, right? That's what it really is. It's looking at it. Owner requirements is a big buzzword you hear with commissioning. What does the owner need? Well, lots of times the owner doesn't know what they need, and they need to be educated on what's important to them. Air, critical, very critical, especially with retro commissioning of existing buildings. New buildings, we can get really good buildings today. I tell people, the passive house people hate me for saying this, but if you design a code building and then build a code building, you're building a pretty energy efficient, durable, long-lasting building. The code, the way it currently stands, if the building is built to it 100%, you will get a really good building. The problem is that what is on paper and what is mainly purchased and then what's actually built, divergent, very divergent. And we need to make sure that people have eyes on it. The special inspections you talked about before, it's not a checklist. And the Building Commissioning Association, their monthly newsletter or their quarterly newsletter is called the checklist. And I speak at the Building Commissioning Association Northeast chapter, and I tell them all the time, change the name of your newsletter, because that is bad. We don't want a checklist. We want every part of that building, every part of that envelope to be looked at, checked. Visual inspection, as much as I believe what we do is very important, it's only important if people take the results that we found and use that to develop an inspection quality control program. So we can find a leak, we can fix it, and then somebody's got to take it and say, we're going to make sure that everyone is remediated and that we check it on the building that it was done correctly. If that doesn't happen, don't hire me. You don't need me if you're not going to follow through and make sure that once we determine what the problem is, it gets followed through. And that's commissioning. That's commissioning, right? Commissioning is making sure that it gets done per the drawings and per every other part of the commissioning process. And testing mock-ups are part of it. Air leakage is huge. Air leakage is really big. Tall buildings, very difficult to get them not to have air leakage and stack effect. And they feed each other. So I tell people all the time, small leaks on the bottom of the building aren't a problem. Small air leaks on the top of the building. So once you get past the middle of the building and the hot air is rising through the building, if it has no place to go, it stratifies and it stays in place. But if it's got leaks on the door thresholds at mechanical spaces in the elevator room or elevator shafts or stairways, that air just fuels the stack effect, that effect where the hot air rises in the building. And you get things like whistling in the lobby, elevator lobbies on the first floor, doors that are hard to open and close, elevator doors that have to be adjusted every season because the force to close the elevator doors change with the back pressure caused by this phenomena. So it affects so many things. Even operation of the elevators is affected by it. It affects so many things, but it really affects money. Operations of the building are affected by poor performing facades immensely. And the problem is that once you build that facade, the cost to get it to perform well is 100 times more expensive than if you just did it right the first time. I can't say this enough to owners and developers and operators of properties. Build it right the first time, it will pay you back for the next 100 years. Build it wrong, you're going to be paying for it for the next 100 years.
Well, so this is a huge topic of contention and something that I still have a hard time wrapping my head around. The whole idea of how they actually measure the thermal performance of the wall. So in following NFRC guidelines, are we trying to follow the NFRC sizes or the job specific sizes? And then when we follow the specs and give that, how is that actually plugged into the energy model so that they're calculating that output for the owner? And then what's actually built, and do the utilities match up with what was actually modeled for the building?
So modeling, NFRC reports, we're trying to get something that's pretty sciencey and pretty advanced technically and get laymen to understand or to use something that's going to ensure that we have a good building. And that's, I'm on the Energy Code Revision Committee at New York City DOB. I'm on the Chapter 17 committee. Awesome people. I love the people at DOB and the volunteers that are on all these committees, but not many of them understand what a BTU is, right? And I don't expect that they will. I didn't before maybe 8 or 9 years ago when I started. I mean, we use the term every day. I can quote you the definition of it, but what does it mean? It's like cubic feet, right? Until I made that analogy with the balloon, people don't really get what it means. So BTUs is a very, very, very tiny amount of energy, right? And when we look at reports that are giving values in BTUs or U value, or actually U factor, which is what we use, it's a rating. It's not an actual measurement of energy that's going through the window, because energy that goes through a window or wall changes by composition, area, delta T. There's so many things involved with it. It's quantifiable, but it's not specifiable, if that's a word. That's a word I just made up. But, you know, in order to get people to give you 75% of what you want, you have to specify 150% of what you need, right? So that's what's happening right now in the building code. We have these numbers that are out there that have safety factors built in, and they are ratings, right? They're not, it's not, there's no way to take a U factor report for a window and apply it to a building and say, I can do calculations based on that report that tells me the energy loss through that window. You cannot do it. You can model that window in LB&L software, figure out its U value pretty well, and then use that on every single window on the building, and then you can do a proper energy model. But no one's doing that right now.
So where does liability come into play? If I'm a building owner, how do I digest that information? I might not actually get what I'm buying.
So there's getting what you need, and there's getting what's required by the code. So the building code, the energy code, has requirements in it for a reason. Again, we ask for this because we know that's the minimum level that will work as we expect the building to work. Does it mean that you're getting the performance levels that you think you're getting? Not all the time. Most of the time it doesn't. And we're going to have to change that over the next few years. We really are going to have to change that, especially on the retrofit and retro commissioning side. A few years ago, more than a few, about 4 years ago now, a year or two before COVID, I was on the Energy Code Revision Committee at New York City DOB. In the middle of the work we were doing for 2 years, I'll never forget, April 18th, 2019, the mayor gets on the news and says no more steel and glass buildings will be built in New York City. And a lot of people, some people laughed, some people panicked. I could tell you I was in a room full of people that day, of people that were pretty pissed off because we just spent 2 years writing an energy code that basically the city council overrode with local law 97, as you mentioned before. And local law 97 is very different than the energy code. Local law 97 says that a building is limited on how much energy it can purchase. All energy, not the energy to heat and cool the building or light the hallways, all the energy for that address based on the use of the building and the size, there's a limit. And we want you to submit all your energy bills every year, add them up, do a factor based on whether you use oil, electric, natural gas, steam for heat, and do these other things, but add up all of the energy that enters that building a year. And if you're over the limit, you pay a fine, basically. There are a lot of other cities in the country that are following this program because you don't need an engineer. There's no complicated, you value this, R value that. It goes by your bills. An accountant can do it, not an engineer. That's because politicians wrote the law, and they wrote it so that an average person could do these forms and file these reports every year. And it's very easy to figure out your fine. It's dollars and cents. That's all it is. And that is coming to a city near you. If you're listening to this right now, whether you're in Denver or Boston, it's coming because it is a revenue booster for the cities. Even though they will tell you all day long that wasn't the purpose of the law, it is a revenue booster in many different ways. If you pay the fine, you're paying money into the coffers of the city. If you decide that you're going to upgrade your building, you're going to promote economic activity by hiring architects and engineers to design upgrades, manufacturers and contractors to do the work, and it's going to work both ways. It's heavy-handed, a lot of people claim. I think it's going to be good for our industry. I think it is the next boom for our industry. The number one thing on everyone's list for these carbon reduction and energy efficiency programs is replace your glazing, whether it's redo your windows, reclad your curtain wall. It is a boost to our industry. However, the liability of not getting it right now isn't going back to that NFRC report and saying, but I gave you the NFRC report. It's not my fault. Maybe you need to lower the heat in the building. No, now it's going to be clear that if they don't hit the numbers that the engineer who did the building energy model for the retrofit put out, and the product doesn't meet the numbers, it's going to be more difficult to actually achieve things, but it is going to be achievable. And it will be, if people were around in the 70s after the first oil embargo in the early 70s and remember what it was like, where replacement windows became a thing right after that. There was no replacement window market before the oil embargo. This is the next oil embargo moment for us as an industry. For the glazing industry, this is the key. For the building performance industry, the passive house people, the energy retrofit people, this is the next boom. This will carry our industry for the next 25 years forward and presents the best opportunity to not shut down float plants and close extruding factories and everything else, because our building stock is old and outdated and needs to be upgraded. This will do that. How we do it, we've been working on some programs to measure air leakage very, very accurately. We have a new system where we use very, very targeted and very, very specific flow meters to measure air leakage through windows at normal pressures. So instead of doing it at the typical window test pressure, which is either a 25 mile an hour per wind or a 50 mile per hour wind, you don't care how much air leaks through your windows at 50 miles per hour or 624 PSF. That doesn't matter to an engineer. Today, 4 mile per hour wind, that's what we need to do it at. So we've developed a multi-point measurement system that can measure all the way from zero differential pressure up to the 50 mile an hour wind. And we use that to model the characteristics of air leakage through a window. And we're developing a whole building method similar to a blower door, but different, where we can measure an occupied building and get a very good air leakage measurement for the overall building to give people a guide so that when they start plugging the numbers into the building energy model, they have a realistic number for air leakage. Because when you do a blower door test, you do it at 75 pascals. Again, that's not a useful number for an energy engineer to use for air leakage. It overstates the air leakage so much that the expected savings will never be achieved because we used we use the miles per gallon if you were going downhill all the time, and that's not what's happening, right? Or actually going uphill all the time. And we've also developed a system for, sorry about the dog. I don't know if you can hear him.
I can hear him.
We've developed a system for measuring U value in place and R value in place on buildings. It's called our heat flux measurement system. And we can go to an existing building and measure the actual U value of the components of a window, and then do a weighted average model, just like we do when we do an NFRC model. We assign areas of that window numbers based on the measurements we take, and we say center of glass is this, and we measure center of glass. Edge of glass is that. We assign an area for that part, and we take a measurement there. Meeting rail, sill extrusion, and we measure 12 to 16 points on a window, and go back with those numbers and build an actual physically measured model of what the U value is on that window, or the R value is on that wall, whether it's the clear area of the wall, the sill plate, the stud, whatever parts of the window we want or the wall we want to measure. And we can come back and tune the energy model so that you have accurate numbers for what that wall's doing, what that window's doing. It's been a passion project of mine to develop this system. We worked with Virginia Tech and Texas Tech, and working with Texas Tech again to develop the physical parts of the system, the technology, software. It's been a project, but we have working models that we've used on a few buildings, and we've gotten great results. And we hope to be able to commercialize it eventually and offer it with training to people in our industry all over the country, so that we can ship out a kit to them. They get trained on it initially. We teach them how to set everything up. They put the sensors on the window. They let it go for 2 or 3 days. They come back, take the sensors off the window, email us the results that we monitored with our system, and we give them back a U value for that window or that wall at the end of the day that they can use however they want.
So that's a good way to measure accurate representation or performance of a window. But what happens if I'm an owner and, again, I specified or I designed this window type with this thermal performance, and now we have, with your new technology, you can come on and test 12 points throughout the frame, center glass, all around, and give them a weighted average and say, this is how the window is actually performing. The problem is, what are you going to do at that point?
So again, remember when I said before, in the window industry, we don't use U values, we use U factors. So it's not directly relatable to the U value. It's sort of the U value of the window, but it's not really the U value of the window. And that's where we have to start relying less and less on that model that we did on an 80 by 80 window, and start getting more people in every company that can do, the therm modeling, and do it on those sizes for the window. Because the modeling software, the therm modeling, the NFRC packages, they are accurate, but they have to be done correctly. So we have to train those people who are running the models to do it correctly. And when I say models, I mean the NFRC model for the actual window, not the building energy model. And we have to do it on every mark number that we're putting on a job. And we can't just say, oh, my window's a U value 0.38. It's not. That was the one that was tested, or the one that was modeled was 0.38. You reduce it from 80 by 80 to 40 by 40, it's going to be a U7.76, not a 0.38 anymore. And, it's very, very geometrically complex, and there's no way it's not linear. You know this, the ratio of metal to glass, everything else has a lot to do with it.
So maybe at some point, could we potentially see some type of field reduction, just like you'd see in water testing?
I don't know if that's going to work, because when we are retrofitting for carbon reduction or for energy efficiency, someone, whether it's the window company, I guess the answer is yes, and we should be doing it now. Like I tell everybody now, whatever the rating is that you're getting from the window manufacturer, if it's a 0.40, underrate it by 20%, 25%, because chances are it's going to be at least that much. And I challenge people to go and try to find data from energy retrofit projects 3 years post completion, and look and see if you can find any LEED passive house stuff in this country in the past 10 years that's looked at 5 years after the retrofit data, and see if any of it comes close to matching what was predicted by all the passive house programs, the modeling, everything else. I'm not saying it never happens. It does. Passive house practitioners that really are professionals and look at every aspect of the project, their projects are awesome. But most buildings are not done that way. Most buildings do not have an energy consultant on site 6 hours a day, poring over drawings during design, making sure that they see everything and model everything. It's not happening. So do we have reduction? Absolutely, we're going to have to. We're going to have to underrate what we're told, because unfortunately, it was done so that we had something we can use. U factors were created so we had some way of gauging one against the other and saying this one's better than this one. But it's not much better than that these days. You know, when we use the U factor traditionally, yes, it gives you an idea, but it's like an A, B, C, D grading system. It's not a 97, 96, 95 grading system. It's a broad grading system that doesn't really allow you to make finite element analysis of a building.
As a final talking point, I think the nice thing about something like Local Law 97 is it's indifferent to how you upgrade your building. If you improve the lighting or the shading or the roofing, whatever you need to do to get to that BTU metric or target that you're aiming for. But the challenge with existing buildings is even with a poor performing envelope, it doesn't matter how much you beef up the mechanical system. If you have a ton of leakage throughout the building, you're screwed. There's only so much you can do. So that's the challenge with existing buildings. But when it comes to new construction, do you see more and more people taking an envelope first approach and trying to target that first and working with their mechanical consultant to then complement one another?
We're not. Maybe you are. You're involved in a lot more projects early on than we are. We get brought in pretty late in the game. But I can tell you that we're investigating lots of projects that can't condition new jobs, that can't condition the space, and they want to know why. And we go in and we say, because current building codes limit the actual number of tons that an air conditioner can be, or BTUs or MBTUs that a heating system can be, and everybody's jumping on heat pumps, which I love heat pumps. I have one in my house. I love it. But those ratings and those numbers are based on a perfect envelope. And if you have less than a perfect envelope, these things are very, very efficient, meaning they don't have a lot of extra capacity. So you can't just say, oh, my boiler's oversized 30%, which we could do in the old days. We could oversize 300% if we wanted. That's illegal today in most states. You cannot use larger than what's prescribed in the energy code. That's fans on ductwork, that's chillers, that's everything. You are limited to your size. And those sizes are based on a perfect envelope. Perfect air leakage, perfect R value, perfect U value. When you don't hit those things, you get condensation building up in a hospital, and we get called to go and figure out why. And I can tell you, most of those calls are U value, R value issues, where, again, I tell people R value is the Federal Trade Commission's definition of resistance of materials to the pattern of heat. It is based on things that don't necessarily apply to real world conditions. And you hear, insulation sales people talk about this all the time. There's R value, and then there's a real world R value. And I always say, well, what the hell does that mean? I never get a straight answer, but I could tell you it's tested under laboratory conditions, right? We get out in the field and it's not laboratory conditions anymore. And I tell engineers and architects all the time, if you do comp check and it says you need R25, you need 4 inches of polyiso insulation, get 5, get 6. The money you spend on extra insulation now pays you back over the life of the building. Any owner developer that doesn't invest in the best glass package they can get in their windows or in the most insulation they can stuff into that wall is being ridiculous. The amount you save, and the banks and the government are also being ridiculous, because to be honest with you, New York City is now putting heat pumps into all the New York City Housing Authority buildings before they are upgrading their walls. Those buildings have zero insulation in the walls, and they are putting heat pumps in every room. People are going to freeze in the winter. And I've had this discussion. I was at an ASHRAE meeting a couple of months ago where they were doing a presentation on this program. And I said to the people in charge of that program, you guys are crazy. If you don't seal those walls, insulate those, get some insulation in those walls, those heat pumps are never going to perform. And I think in the next year and a half, you're going to see that the pilot buildings that they're doing are going to be disasters. And we see it. There's a lot of data from the UK, who was about 10 years ahead of us on this heat pump thing. And now the big thing is, if you don't do the envelope first, the mechanical upgrades you're going to rip them out. And they're ripping out heat pumps all over the UK because of that.
All right, Eliot, this was an awesome conversation. I think there's a ton that you can learn from him building envelope testing. So what's the best way for people to reach out to you if they want to learn more?
bet-na.net. We're on the web. I'm on LinkedIn a lot. I post a lot on LinkedIn. Just look up building envelope testing. Will come up. I'm happy to have done this. I appreciate it. I want to thank you so much. I know we went way over our time. You're going to have a hell of a time editing this, but that's okay. And
it was worth
it was.
All right. Thanks, Eliot. It was great catching up, and hope everyone enjoyed it.
Thank you, Adrian.
Cheers.
Cheers.